Basics of organic reactions. First of all, I would like to separate that there is a three types basics of organic reaction. First one is mechanisms. Second, types. Third one is effects. These basics of organic reactions in 11th standard, which is the 12th lessons, we will have the 12th lessons in the 11th standard, okay, which is a very important topics. That's why I am taking these topics, and more concepts are occur in these topics. Okay, now we would like to see the basics of organic reactions, which is the three types: mechanisms, types, effects. Okay, now first one is the mechanisms. Dear students, first you should know what is the mechanisms. Mechanisms are intermediate. For example, I would like to give you an example. For example, I will take the bike. Okay, bike. Suppose we want to go the bike. What happen? Which bike using fuel and it's moving. Some things it is going to moving. For example, we will come to from home to school. What happened? The bikes are moving. How it is moving? The bike occurring some mechanisms intermediate. What is the intermediate in the bike? Engine, fuel. What is the fuel is going to the engine? It's burning, and mechanisms. Some mechanisms are activate. And what happened? The wheel will be rotate. Okay. Now like that in organic reactions also some mechanisms occur. Intermediate products. What happened? For example, I will take a reaction. For example, simple reaction I will take. Okay, what happened? Now, for example, CH3 halogen compounds, which is the halogen compounds. We will add something H2O, OH. Okay, what happened? This CH3 halogen compound become CH3 plus X minus. Okay, these two compounds like water molecules is separate. H plus, what happened? Which is H plus OH minus, which is attracted to CH3. Okay, this electron is attracted by CH3. This H plus is attracted by X minus. Okay, it become the product CH3OH plus HX. X means halogens. Okay, this is called intermediate. Product. This intermediate has different types. Intermediate, we can tell fission. Okay, fission. What is meant by fission? Fission is called breakage of covalent bond. Fission is called breakage of covalent bond. We should know before this topic what is the covalent bond. What is the covalent bond? Mutual sharing of electron. Mutual sharing of electron. All organic compound should contain only the covalent bond. Okay. Now fission is two types. Okay. Fission is two types. Homolytic fission, heterolytic fission. What is my lytic? Decomposing. What is my decomposing? Okay. Decomposing is called lytic. Okay. Now, what is the homolytic? Homo means, what is the homo? Homo means same. Okay, same sort. What is meant by homo? Same. Lytic means decomposing. Now, we would like to see the homolytic fission. Example. For example, we are taking a compound C bond. It is the covalent bond. bond. This covalent bond is mutual sharing of electron. Okay, you know what is the covalent bond because before lessons are chemical bondings also you have seen before. Okay, now covalent bond, the bond containing two electrons. Okay, there is the two electrons. This is the orientations. Okay, this orientation, why it is the orientation is necessary? Suppose the orientations, opposite orientations. Okay, this one is restricts, suppose it is the stop the reflections between the electron. Both electron is negative charge, you know. This opposite orientation which is restrict the, what is that, restrict the, what is that, repulsions. Okay, repulsions. So that's why it is the orientation is very very important. Now this is the mutual sharing of electron. What is the meaning of mutual sharing? A can give one electron and C can give another electron. Sharing, it is not donating or accepting. Okay, it is the sharing of electron. Now fission, homolytic fission, what happened? This unpaired electron, okay, this unpaired electron, suppose the carbon shared one electron to the A, whatever it may be, atoms A. What happened? The carbon attract their atom to itself. Okay, it is the bring itself. Okay, this electron is bring itself, it will become C dot. Okay, C dot, which means radical, another A atoms also become like that. This electron is called unpaired electron. Okay, this electron is called unpaired electron. This electron also unpaired electron, and then we can call it is the free radical. Free radical, what is meant by free radical? Are formed breakage of molecule. When it is formed free radical? When the breakage of molecule. What is meant by? These are molecule breakage. Okay, what happened? Breakage has happened. Both free radical has to be formed here. Okay, now we can take a methane molecules, which are also single bond molecules. There is no double bond. Okay, it will be separated, it will become the free radical. Now free radical lifetime is very very short, 10 power minus 6 seconds, microseconds. What happened? It is a 2 very 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 short times. Okay, so it is not stable. Okay, for example, we can take hydrogen molecule. What is meant by hydrogen? Hydrogen is a diatomic molecule. Okay, diatomic molecule. What happened? Diatomic molecules is purely covalent bond. Which one is the purely covalent bond? Is separated. Okay, what happened? It is breaked. It's become 2 hydrogen radical. Okay, 2 hydrogen radical. This 2 hydrogen radical, what happened? It is not stable, but it is more reactivity. Which is the more reactivity? And then chlorine, like chlorine, fluorine, nitrogen, whatever it may be, which is the more reactivity of the atoms. Now we can call atomic hydrogen. Okay, can call it is the atomic hydrogen, otherwise nascent hydrogen, otherwise radical of hydrogens. We can call it is the radical of hydrogens. Now next one is now you can see here this dot, this dot is denoted unpaired electrons. Okay, this dot is denoted is unpaired electron. These are available. CH3 free radical is also available. Next, ethylene free radicals also available. His halogen free radicals also available. Next one is a heterolytic fission. What is meant by the heterolytic fission? Heterolytic fissions. Next up is the heterolytic fissions. Here there is no free radical is possible here. Okay, heterolytic. Hetero means, what is meant by the hetero? Different. Already we know what is the lytic. Lytic means decomposing. Okay, now ionic intermediate. What is meant by ionic? Ionic is ions. What is meant? How many types of ions is possible? One is either positive or negative. These ions are only two types. Ions are two types. Okay, now here organic reactions also containing the two types of ions. One cation, another one is the anion. Okay, now I will take one example. For example, it is RX. These organic compounds, which is the halogen. What is meant by halogen? Halogen means fluorine, bromine, iodine. These are halogens. Okay, either whatever it may be, I will take the chlorine. Okay, what happened? Chlorine. This chlorine is attached to the methyl groups. Here we should know that which is the most electronegativity compared to carbon and chlorine. Which is the most electronegativity? Yeah, you are correct. The chlorine is the most electronegativity. What is the electronegativity? The tendency of attract the shared pair of electrons. Okay, the tendency of attract the shared pair of electron towards itself. Okay, it is attracting. Okay, attracting. Which is the electron is present? The mutual sharing of. Already we know that. Okay, mutual sharing of electron. That's why it has the delta minus. Okay, which is the delta plus. Okay, which is the delta plus. Now what happened? Here this chlorine is attract the shared pair of electron towards itself. What happened? It is bring the electron and go with Cl minus, and which is the positive things. Okay, which is the positive. We can call it is a carbocation, and also it is not stable. Suppose we are comparing inorganic compound and organic compound. Which is a stable one? It is the comparisons. Okay, it is not more stable. Suppose compared to CH3, Na plus is more stable. Na plus is more stable, and Cl minus. When it is here, the Cl minus is more stable, but here it is not stable because it is the ionic bond which is donate. The Na plus is donate to the Cl. It's become the chloride. Okay, that's why it is here more stable, here less stable. Okay, the organic compound, it is also very less stable because it is the covalent bond, which is ionic bond, which is the covalent bond. Okay, and it is coming Na plus Cl minus. Na plus is more stable compared to CH3 plus. Okay, CH3 plus. Now we can see carbocation. Okay, carbocation, and which is a anion. Halogen anion. Already we can see ionic intermediate is two types. One is the cation, another one is the anion. Here radical. Okay, here the radical, but here anion and cation and anion. Okay, now it is a heterolytic fission. Now I would like to see the intermediate. What is intermediate? Now we can see free radical is one of the intermediate, another one is the carbocation, and third one is the carbon ion. Okay, what is meant by the carbon ion? Carbocation, the carbon become the cation. Carbon anion, the carbon become the anion. Okay, I would like to give one examples for this one. Suppose the cation C halogen. I will take the halogen. Okay, I will take the halogen. this halogen group is attached to the carbon group. Which is the more electronegativity? Yeah, you are correct. The halogen group is the most electronegativity compared to carbon. We should be compare. Okay, we should be compared to the carbon. Compare carbon. Suppose we have to compare the carbon. X is the most electronegativity. That's why it's become CH3 plus X minus. Okay, now here I would like to come here. What happened? Carbon, at the same time hydrogen. Which is the most electronegativity compared to carbon? Carbon is most electronegativity. It is become carbon minus. Okay, H plus, that is called carbon ion. Okay, these three free radical, carbocation, carbon ion, these three intermediate is possible. These three intermediate is possible. Next we will come conclude intermediate. What happened? Free radical, ionic both carbo cation or carbon ion. Okay, now the addition of third and fourth, which is electrophile and nucleophile. What is meant by the phile? Phile means liking, loving species. We can call it is the loving. Okay, which one is the loving? Electrophile. For example, electrophile means, nucleophile means love. Which one is love? Nucleus. Okay, nucleus, which is going to be attracted in nucleus. Okay, what happened? Suppose, what is the charge of nucleus? For example, here one atom, this is atom, this nucleus. What is the charge of nucleus? Nucleus only the positive charge. Nucleus only the positive charge. Who can be attracted? Only the negative charge. Okay, that's why nucleophile is negative charge. Nucleophile is negative charge, either neutral or negative charge, either neutral or negative charge. Okay, now we can see, this is one negative, this is one neutral. Okay, neutral, this is the negative. I just changed that one. Okay, negative charge. Okay, what happened? Negative charge means electron rich species. Neutral means it is also electron. Suppose we can see the lone pair electrons. Okay, lone pair of electrons. It is also electron rich species. Electron rich species. This is called rich species. It is also electron rich. This is called nucleophile. You can call it is the nucleophile. Phile means liking. Nucleophile means nucleus liking. Okay, what? Nucleus liking. Who can be nucleus liking? The negative charge only can be nucleus liking. Here, the how it is the lone pair will come. Okay, you can see that it is very simple. Already we know, but I will tell again. Okay, what is the electron? What is the atomic number of oxygen? Yeah, you are correct. 1s2, 2s2, 2p4. Okay, 2s2, 2p4. What happened? It is inertial. We should believe it 2s box putkalam, and then okay, these 2s and the 2px, these are lone pair. Okay, these are lone pair. These are lone pair is here. Okay, then H2s also one of the neutral. Okay, neutral nucleophile. Okay, these are the electron rich species, oxygen and sulfur. because of the lone pairs, because of the lone pair. Now we like to see the electrophile. What is meant by the electrophile? Here also possible neutral and positive charge of electrophiles. Okay, electron deficiency. Okay, electron deficiency we should not call proton rich. Why we cannot call it is the proton rich? Because the proton rich means it should donate the protons, but it unable to donate the protons because of the organic reactions only happen in the electrons, not in the nucleus. That is different reaction, nuclear reaction. We should not go for that one. Okay, now it cannot be say proton rich. It can be say what happened? It is the electron deficiency. Okay, what electron deficiency? Can call it is the electron deficiency. It's electron deficiency where it can be attracted to the electrons. Okay, electrons. Here neutral. Okay, neutral BF3. Okay, what happened? Boron. Boron atomic number. What is the boron atomic number? Pi. 1s2, 2s2, 2p1. Okay. What happened? The outermost shell. We can call it is the outermost shell. 2s2, 2p1. 2s2, 2p1. Okay. Now these 3 electrons is available in the 2s and 2p1. What happened? 2x we can separate 2p, 2y, 2py, 2p is that. What happened? This 2s1. Okay, but this electron is exciting here. This pz is going to be 0. Pz is going to be 0. The f is going to be contributed with 2s, 2px1 and 2pz1. What are contributions? What happened? This outermost shell, here 3 electrons, here 3 electrons. What happened? 6 electrons only possible. That's why this 2pz box will be going to be 0. It is the electron deficient molecule, which is the electron deficient molecule. We can call it is electron deficient molecule.